back to Basic Advanced Math. Today we're continuing. Today we're continuing the Calc BC / Calc 2 section. Hope you're doing well today. If not, that's okay because people will change on you. You know who doesn't change on you? That's math most of the time. So let's get straight into it. Today we're going to be talking about integration by partial fractions. Basically, what partial fractions consist of is breaking down fractions into smaller fractions you can solve for the constants for. The hope is that you're going to be able to integrate those fractions by themselves so that you get a total integral of the original fraction. Might sound confusing, however, I want to show you what's happening. It's going to be easier to understand. All right, so here we go. So you want to integrate this equation, x over x squared plus 4x. How do we do that? You probably don't know. If you do, it's going to be really difficult to integrate straight up in this form. So once again, like everything we do, we got to try and get it into a form that we can integrate. How we're going to do that? We're going to set it up into two different fractions. You can see that the bottom right here will split into two different fractions that both involve terms. I'll show you what that means right now. So the bottom part of the problem, x squared plus 4, the highest term of x is x squared. The power of that is 2. That means that you know you're going to be breaking it into two different fractions. If it was x cubed was the highest one, you're going to be breaking it into three different fractions. It just depends on which one this is. Each fraction is going to have its individual x. So you break this down into two different fractions. The only way to do it with two different x's, one of them is going to be x, the other one is going to be x plus 4. Let's write that down. You can see that these two terms multiply to make x squared plus 4x. So that's when you know you did it right, when they all multiply to make the original term. Now, the thing that you got to solve for is up here. What's right here? What's right here? We're going to call these a and b. So we have our two terms right here. Now we're going to have to try and solve for a and b. The way that we're going to do this is going to seem a little bit weird at first. However, once you get used to it, it's going to get a lot easier. So let's get straight into that. What you're going to do is you're going to take the top of the original fraction and you're going to write that down. That is going to equal these two terms cross multiplied. You're going to take a and multiply it by x plus 4. That's going to be a times x plus 4. Super easy. You don't really want to simplify right now. You could say ax plus 4a, but that's going to make things harder. You don't want to do that right now. I'll show you why in a second once you start solving for these variables. The next one, of course, is just going to be the opposite. It's going to be bx. So now the next step is to solve for both a and b. How we're going to do that? It's pretty simple. It's how you solve for most equations. You could plug into your calculator with the function that's in there, assuming you have an advanced one like the TI Inspire. However, we're going to do it really quickly by hand. It's not going to be very difficult. So what we're going to do is we're going to set one of these terms equal to a number that'll cancel it out, make it 0. So say we set x equal to 0. That would make bx equal to 0. That means that we can solve for just ax. And we're going to do the same thing for the other side afterwards. So first, to solve for a, we're going to set x equal to 0. Once x is equal to 0, we simply plug it into this first formula right here. So we see that when we plug in x equals 0, we get 0 equals 4a. It's a times 4 plus 0. 4 plus 0 is 0. Don't be dumb. So we get 0 is equal to 4a. So of course a is equal to 0. And that's going to be our final answer for a. Now the next part, we want to try and get bx by itself. So what we're going to do is we're going to set a times x plus 4 equal to 0. How are we going to do that? We're going to set a equal to -4, so it cancels out that term altogether. So of course, when you set a equals to -4, this is going to go down to a 0a, because it's -4 plus 4 times a, that's 0 times a. When you set x equal to -4 on the other side, it's of course going to equal plus -4 times b. And then you set it equal to something, set it equal to x, x is -4, so you're going to set it equal to -4 as well. So you see you got -4b equals -4. You solve for b, you're going to get b equals 1 altogether. That's going to be a final answer for b. So now we have our terms, we have our constants for the fractions. We have a equals 0, b equals 1. We're going to rewrite those up here. And now it is finally going to be time to solve for the integral. We're almost done. We've gotten through the hardest part. It's just plugging stuff in and actually integrating the equation. So when you plug in the constants to the equation, you get the integral of 0 over x plus 1 over x plus 4 dx. Now you're in a super good position. We're going to get rid of the 0 over x, and then we're going to be finally ready to solve for the integral. So now we're finally left with the final integral that we're going to have to actually integrate. We get integral of 1 over x plus 4 dx. If you remember from the derivative rules and your integration rules, you will know that the integral of 1 over a term is going to be the natural log of that term. So when we finish this out, you're going to get the answer of natural log of x plus 4 plus c. That's your final answer. You got to remember the plus c. That's going to be a killer to everyone and their mama. The main challenges in this is going to be able to solve for the constants. Once you're able to solve for the constants, everything else is pretty easy. You got to identify what integration method to use. Once you get all that done, that's really all you're going to have to do. I believe in you, as always.